Hey everybody, this is Larry. This is day 6 of the December Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about today's problem. Populating next right pointers in each node too. And I usually solve these live, including the explanation. So if you want to jump to a solution, go on 2x or jump near the end. Yeah, let me know what you think about this format and let me know about your questions. Okay, so let's see, what do we want? So basically, we're given a tree, which also have a right node, and we want to connect them. Okay. There are a couple of ways you can do this, and I think it depends on how you want to do it. If you want to use constant extra space, that's going to be a little bit trickier. Recursive with implicit stack doesn't count extra space. Just seems like really weird cheating or something like that. But really, we can just do a level, what's it called? Level order first, level first search, or per level search or whatever it's called. But basically, and it is kind of what it sounds like, right? For each level, you just go to the next level, and then for next level, you just point them together. It is gonna not use. So if you do that, that's gonna take linear extra space because you're putting things on a queue or something like that. You can also use something like that, but I'm not gonna do the constant extra space one. I think that just takes way too much effort. And you can also do this recursively, of course, if you just find out what the recurrence is, right? And also just try to figure out what the invariants are. And the invariants are what, as I always say, the things that don't change when other states around it change. But I am going to do, for this one, going to do a level order search. It is something that I actually have not practiced that much because it doesn't really come in that much. So because usually you just do by first search. So yeah, so I'm going to practice that. And I'm going to do this live. So let me know what you think. So basically, yeah, the algorithm that I'm going to do is just do it one level at a time. And then for each level, we put next level as in the process. And that's pretty much it, really. So, okay. So let's say level is equal to empty. Next level is equal to also empty. Actually, let's do current level is equal to root, right? And then we can do yeah, while length of level is greater than 0, that means we have something to do on the next level. So next level is equal to we don't even need it. Yeah, so next level we just set it to empty, and then for node in level, next level dot append node dot left and node dot right. Of course, we have to do some things to just basically check that they're not nuns. So yeah, so if node dot left is not none, if node dot right is not none, right? And that's pretty much it, kind of, maybe. And then level is equal to next level, right, at the very end. But before we do that, it doesn't really matter the order we do it in, to be honest. But now we want to connect adjacent nodes, right? So for previous node in the zip of level and level suffix. So this basically gets us two adjacent nodes on the same level. So previous node dot next is equal to node, and that's pretty much it. And I think we have to just return the root, I think. I mean, we return a node, but I guess it's not really clear which one, but which other one would you return, right? So yeah, so that looks good, I think. Boring. I wish they kind of gave a little bit more, but let's give it a submit. Ooh, one timeout. Oh, I usually am a little bit careful about it, but I think today I'm just a little bit tired. That's my excuse. I'm sticking to it. But yeah, it's just that that's the only case where we don't check for none. So we can do something like if root is not none, we could do this, which preserves the symmetry that we see here. Level used before assignment. What? Oh. I am being careless. I'm watching a little bit. This should be empty, and then this should be level.append root to also keep it consistent with the other stuff, right? And this is why we test things, I suppose. Cool. Looks okay. A little bit careless today, to be honest. On the contest, I have 4 wrong answers, and here I messed up a really obvious example. But now I have accepted, and that's good. So what is the complexity, right? Well, it's going to be linear time because we look at each node at most once. Well, constant amount of times for each node we put it into the next level once, and then it is in the level once. So we put it in to next level once, and then we take it out of level once, right? So it's going to be O of 1 per node, and therefore it's going to be O of n. In terms of space, level we actually add a lot of stuff to level, so it's going to be O of n because each node goes into level and next level. So yeah, that's all I have for this problem. I am a little bit tired today, so I'm not going to upsolve it, but let me know what you think. Let me know how fast you got this, because this is something that's standard, and it is the first time that I implement level first search or whatever it's called in a long time. So it is something that I'm happy to kind of do it relatively quickly, even though I had a mistake. Yeah, so if you do it with depth first search or breadth first search, try to do it with another search. Let me know how you did it and how you prefer it. That's all I have for this problem. I will see y'all tomorrow. Have a good night.